Let's see the definition of some important quality parameters and we'll try to understand their physical meaning. We are not going into a detailed definition of these quality parameters. Uh, Basically, they are based on simple geometry formulas for 2D and 3D space shapes. And the fact is that most these definitions are slightly different in different softwares. So we are not going into a detailed definition. And other important point is that most of the softwares nowadays have very robust and superior meshing capabilities, uh, and therefore we don't spend a lot of time in meshing. We generally preset some mesh rules, okay? And for example, like we tell the software we want particular element quality parameters in so and so range. So we preset some mesh rules, and then we execute a meshing. We click the meshing button. So the meshing algorithms inside the softwares, okay, they try to mesh while confirming the user inputs. So the most of the times the element qualities are very good, but still after meshing we need to check or monitor uh, some important quality parameters. So let's see uh, the few of them. So first thing is aspect ratio, which is very important, and it is defined as the ratio of longest element characteristic dimension to the shortest element dimension. So we know this for tri-element, this is the minimum length, element length, and this is the maximum. So the aspect ratio definition is L min, it is L max by L min. Similarly, for quad element, this could be a minimum element age length, and this could be the maximum. For 3D elements, the TET element has 4 faces, so we need to find the aspect ratio of all 4 faces, and aspect ratio of a 3D element is highest among these 4 aspect ratios. So highest aspect ratio out of aspect ratio of this 4 faces. Similarly, for hex element, it has 6 faces, and the aspect ratio is the highest among these 6 faces aspect ratio. What is the recommended or no, acceptable aspect ratio that we need to maintain in our meshing? So for critical regions, uh, it should not be more than 5. Okay, so 1 to 5. For non-critical, we can go up to 10. So it is okay to maintain 5 to 10 aspect ratio in non-critical regions. Again, this is industry standards. Okay, each industry has a different meshing guidelines or standard values based on their previous years of experience, okay, and their experience with working on different projects. So there is no reinforced no guidelines that we need to follow, but definitely if you want to start with this could be a recommended range. The next is skewness. Skewness, it measures how much element is distorted from its ideal shape. For example, for tri-element, the ideal shape is equilateral triangle. Okay? All 3 corner angles are 60 degrees. So the ideal value, okay, is 0. So the skewness is 90 minus smaller interior angle. So for this tri element, this is the interior angle. Okay, so we can say it is a 90 minus 90, which is a 0. Since this is an ideal shape, so ideal value is 0. Okay. If we take skewed tria element, okay, so we can say the skewness is 90 minus interior, smaller interior angle. Okay. So this is a bigger and this is a smaller interior angle. So we should take this one. So 90 minus theta is the skewness of triad. Same goes with quadrilateral element. So in terms of skewness, the ideal shape is a rectangle or square. So the ideal value is 90 minus smaller interior angle, which is 90. So this is 0. And this is a skewed quadrilateral element. Okay. So the definition is uh, simple. It's 90 minus the smaller interior angle, this theta. Okay. So the acceptable range is no, it should be somewhere less than 30 degree. Okay, this is acceptable for skewness. Okay, 30 degree. Warpage, it measures how much element in case of 2D, and in case of 3D it is element phase. So how much element phase deviates from being planar, and this definition only applies to quadrilateral or hex element. The definition is that the warpage is angle between two tria-face normals. So we know any plane passes through 3 points, okay, and when the fourth point is introduced, the plane is no longer planar, right? So for example, this quadrilateral element, okay, we can split it into two tria faces, right? Because they are not planar. All 4 points are not planar. So it can be imaginary. We can split it into two tria faces. So this is called warpage. Okay, how the element face, okay, is not planar. So it is angle between these two tria face normals. Okay, so we can say this is the angle. So this doesn't apply to triangle tria element because tria element is always planar. Similarly, for hexahedral element, we have six uh, faces of hex element. So we get six warpage values for hex element, and the warpage of hex element is the uh, worst warpage of these six faces. And the acceptable range is less than 20 degree for critical regions, whereas non-critical regions we can even go with the higher warpages. It should be around 40 degree, less than 40 degree. Okay, so these are the important quality parameters: aspect ratio, skewness, and warpage. There are some more element quality parameters. For example, Jacobian. This we have seen in earlier or previous lecture, and not all the softwares report Jacobian. Okay, very few softwares they show the Jacobian. The Jacobian is basically the collapse indication of the element, okay? So it is overall definition. Okay, it also defines shape factor, size factor, and also collapse. So Jacobian is also very important quality parameter. Apart from that, there are so many other quality parameters, but there is also something minimum length. So out of all the elements, whichever element has the minimum length, that is the quality parameter. And this is not so important in static or no, implicit analysis. This is very important in case of explicit analysis, because in explicit the stable time increment which is which is determined from the minimum element length. So there it is very important. So we are not going into explicit, so we are not going to discuss this minimum length, how it affects explicit solver. So basically these are the few quality parameters. If we monitor, that is more than sufficient. Aspect ratio, skewness, and warpage, and Jacobian if it is available, it is better to check Jacobian as well.